Today's show is sponsored by Do It. Cloud spend is just the surface. What really matters is how it drives performance, reliability, and speed to market. Do It Cloud Intelligence aligns every dollar to the intent of the workloads. Do It is trusted by companies like Fiverr, HackerRank, Current, and Superbet. Do It helps teams go beyond dashboards, surfacing hidden inefficiencies, resolving incidents faster, and aligning cloud operations with business priorities. One platform, unified signals, better outcomes across engineering and finance. Visit doit.com, that's DOIT.com, to unlock intent-aware FinOps at scale. Do It Cloud Intelligence.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Hello, everyone, and welcome back to the Cloudcast. It's Aaron, and I'm here for another quick intro before we jump into this week's interview. I chose this topic this week because I believe it's increasingly overlooked in the AI community. While for some organizations, and certainly most consumers, AI is often a cloud-first model, there are many organizations, especially in highly regulated industries, where cloud AI is simply a non-starter. That's why this week we are discussing private AI stacks and how CI/CD impacts this operations model. Hopefully it's a fresh perspective for some of you and you'll find this interesting. And lastly, a quick programming note. We are about to start booking shows for the fall. So if you have any ideas for topics or guests, please send them to the show account or to me directly. With that, on to the show after this quick break.
Today's show is sponsored by Factor. Is your help desk still asking security questions like, what's your mother's maiden name to verify callers? If your organization uses Okta, Factor Identity Portal transforms caller verification, allowing you to authenticate users instantly using their Okta-enrolled MFA factors like SMS and Okta Verify. Reduce call times by 60%, eliminate social engineering risks, and streamline help desk operations with one unified dashboard. Check out Factor's Taco AI, the first AI agent for Okta, on their website. Visit factor.io, that's FCTR.io, and you could try it free for 60 days. Time to retire those security questions and switch to 2025 standards. Today's show is sponsored by Vasion Print. The problem with print is it's a resource suck. IT teams are spending too much time on troubleshooting and upkeep. The biggest offender? Print servers. So get rid of them. Swap your outdated, resource-intensive infrastructure for Vasion Print, formerly known as Printer Logic, and get serverless, direct IP, secure printing for any device, anywhere. Centralized print management reduces overhead and workload and increases productivity, which is great for your IT team and your bottom line. Increase security, remove scripts and GPOs, and enable self-service user deployments. Secure, seamless, and scalable. That's what you get when you eliminate print servers. See how at vasion.com.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And I have a great show for you this week. It's a topic that I've been meaning to dig in personally for quite a while because it kind of overlaps with my day job a good bit. And that is this topic of private AI and this concept of how do you integrate that into existing workloads and existing stacks in organizations. And for that, today, we have Luke Marsden, CEO and founder at Helix ML. So first of all, Luke, welcome to the show, and give everyone a quick introduction, please.
Cool. Hi, Aaron. Lovely to be here. Thank you for having me. And hi, everyone. My name is Luke Marsden. I'm the founder and CEO of Helix ML. And I'm a sort of 3-time founder person. So I've done a bunch of startups. And so early in my career, I worked a lot in DevOps around containers and Docker and Kubernetes, kind of back in the early Docker Kubernetes days. We did a company called Cluster HQ that did storage for Docker, and we were involved with the Docker ecosystem early on. And then I did my second business was called Dot Science, which did an end-to-end MLOps platform, which was all around this was machine learning before GenAI took off. And so we were looking at how you conversion the training data that goes into models and then deploy those models into Kubernetes and do monitoring of those models and trying to sort of close that loop and apply like software development lifecycle best practices to to ML. I then went and did consulting for a few years, and I did consulting on MLOps in clients or for clients all over the world through the time that the ChatGPT moment happened. And so I saw kind of firsthand the effect that GenAI kind of becoming real had on businesses all over the world. And in particular, I remember one particular client we worked with is a company in the US that makes nuts and bolts and machine parts. And they were fine-tuning Llama 2, like when Llama 2 came out. And I was like, what is this company, like this old company that like is very much in the real world, in the manufacturing space? Why are their exec teams spinning up like a project to fine-tune Llama 2? And I realized it's because forward-thinking boards, like forward-thinking executive teams, were realizing that the massive impact that machines mastering language was going to have on their entire business and the way that they operate. So I saw an opportunity kind of in late 2023 to have another go, basically. And that's why we kicked off Helix ML with a focus on private deployments of open source models into enterprise. So I don't know if you want me to dig more into that.
No, that's We'll dig into that, but I also just wanted to make a comment too, because this podcast has been around for a number of years, and we've been kind of riding the technology waves, if you will. And I think something that honestly, we've done a lot of AI shows, we've done a lot of DevOps shows, we've done a lot of cloud shows, but we haven't really talked about this creation of these stacks, if you will, especially in the concept of, okay, what does it take for the underlying infrastructure to run on Kubernetes or to run, with Docker and complementary to containers? And so I wanted to really explore that today, but let's kind of start at the concepts and then we'll work our way down to the tech. Sure. Let's start with Private GenAI. Like, what is it? What's your definition? It's almost like the early days of cloud. What is cloud, right? Yeah. Like, what should organizations be thinking about? How should they be thinking about this? And then I'll throw you the softball question of like, hey, why not just use OpenAI GPTs and throw a bunch of data at it and fine tune them, right? Tell me what it is and why we need it.
Sure, and I mean, I think as you have like executive teams, boards in big companies saying like, we can see the transformative nature of GenAI in terms of being able to improve efficiency, accelerate like what we can achieve, like basically like use these like amazing new information processing systems to like speed things up and become more competitive and come up with new innovations and so on. There's this top-down kind of business driver to do that. What that means is that all of a sudden, kind of the platform teams, the DevOps teams inside these organizations are going to be and are already starting to get questions like, well, how do we do that? Like, what is all this new stuff? It's like the early days of Docker and containers all over again. It feels like that, but with more of a top-down pressure from the execs. Because actually, I was speaking to a friend of mine the other day, and Penny, and he was saying like, we never had CEOs saying you have to use Kubernetes, but you do now have CEOs saying like we have to like ramp up on GenAI. So yeah, what is this stuff, and like, and how do you start to bring it into your business? Well, I think the obvious thing to start with is the models. So these large language models are basically very, very big mathematical functions that turn sentences into sentences. That's a bit of a simplification, but that's basically what they are. And they need a lot of compute power to do that quickly. So you run them on something called GPUs. GPUs were traditionally used for like video cards for gaming, because like when you're rendering video games, you do like these massive like parallel vector calculations. But it turns out someone clever realized in like the early Transformers work that you can reuse these graphics cards for running large language models. And so these large language models are basically these big fat mathematical functions that turn sentences into sentences. And they can do that in such a way that they kind of predict what's the most likely next word or next token. And then you can give them questions like, what is the capital of France? and it will predict that the most likely next word in the response is Paris. And so that's a building block. Like you don't just need an LLM, but what you do need is you need an LLM, and you have two main options. The first one, as you mentioned already, is to just go and consume these LLMs from an external service like OpenAI or Anthropic, or Amazon, Google, Microsoft, etc. Or you can run one yourself on your own infrastructure. And if you do that, then you need to start thinking about GPUs. Now, it's possible to run GPUs on your existing infrastructure. You might not have any yet. If you have a data center, you might need to buy some and actually run them like on machines that are in your Kubernetes clusters or however you're doing your infrastructure. If you're in the cloud, then you can provision them in your VPC and connect them similarly into your clusters. There's like an NVIDIA device plugin for Kubernetes that allows you to provision these things and then just deploy services onto them. But that's the LLM is just the starting point. It's like a tool, and you can ask it what's the capital of Paris, or like can you count the number of R's in strawberry, which famously LLMs were bad at, and things like that. But it's not very useful to just have that on its own in a business. What you then need is to connect your business data to this LLM in a way that allows you to process that data. And so that's where you then get systems like RAG, which stands for Retrieval Augmented Generation. I prefer the phrase knowledge because RAG is a fancy acronym, but really the idea is just like bringing knowledge that's relevant to that LLM. And you might have heard of a thing called a vector database, which is how you can put your documents into a system that allows you to then retrieve them based on finding things with similar meaning and then bringing that into the kind of the context window of the LLM. And then other things you can do are like API integrations. So you can sort of imbue the LLM with the ability to make API calls on behalf of the user. And then you can plug it into systems like your product catalog. So, for example, we have a customer who wanted to rent heavy machinery in Europe, and they wanted to enhance their sales team so that their sales team could help people out of hours and when they were out of capacity. So they wanted to make it so that you could send an SMS to a system and say, do you have any cranes that are available to rent in Hamburg next Thursday? And the thing would need to go and construct an API call to query, I think it was their Salesforce instance, to be like, what's the availability for cranes? And then summarize the response back to the user via SMS, all within a few seconds. So yeah, these are the kind of things that you need to then construct like around the LLM. And I can go into loads more detail about that and talk about Vision RAG and other cool stuff, and Auth, which is always fun in enterprises. But that's kind of the broad picture.
Well, and so let's actually take that one step further. Then let's kind of break down those kind of layers in a typical AI stack or a private AI stack. I've seen various ways, and I come from an infrastructure background. So like you always kind of have the infrastructure layer, you always have the model, and then you kind of have the MLOps layer and the MLOps tools. And of course, like the data layer, like we were talking about with RAG and a vector database and some of these other things. But how do you think about breaking the stack up into the individual components? Like if you had to kind of, go to the bottom to top, what are the pieces that for you are the different pieces that need representation? Yeah.
And so my view of the stack is pretty clear in my head. So the base layer is private infrastructure, although I'm biased, but I believe that people should run open source LLMs on their own infrastructure most of the time. So private GPUs on your own metal or in your own VPC. And that layer, it comprises of, let's say, a Kubernetes cluster with GPUs available to it with the NVIDIA device plugin enabled, right? So that's like sort of infrastructure layer. And then on top of that, you need some sort of control plane. And the control plane, above the private infrastructure, you need some way of managing the GPUs if you are going to run your own models. And so you need some way of managing which models are deployed on which GPUs and when, and how do you scale them in response to demand for different types of models. Now, I might be biased, of course, because at Helix ML, we developed this GPU scheduler. We looked at what you could do in terms of GPU scheduling on Kubernetes and discovered that it wasn't flexible enough for what we wanted to do. And this actually came from a place of, the saying, like, necessity is the mother of invention. Like, we were starting out in December 2013, and like we didn't have many GPUs. Like, we just literally had a few like 4090s lying around in our own little mini data center. And we were saying, like, how can we actually run a service that hosts like Mistral 7B and like stable diffusion and fine tune some of these models, and how can we mix and match those and change which models are running on which GPUs in response to demand. And what we found was that the Kubernetes primitives for requesting GPU memory are actually not very good. You can't actually say, I want 8 gigabytes of GPU memory, please, and then have Kubernetes automatically pack like your 8 gig models in chunks into a 24 gig GPU or a 40 gig GPU or whatever. All you can do with Kubernetes is say, I want 1 GPU, or I want 2, or I want 8, or whatever. And so that sort of fine-grained memory bin packing wasn't there. So we invented a scheduler to do that based on GPU memory. It is possible to like subdivide GPUs on Kubernetes, but actually you end up in a big mess if you try and do that. And I won't. We can dig into that if you like. But anyway, that's the sort of GPU scheduling layer. So you can either do that just with Kubernetes, or you can use something like our GPU scheduler, which maybe gives you better like performance and lower cost because you can pack things in more efficiently. So yeah, there's your private infrastructure. There's your GPU scheduling, like how do you actually allocate which models are running on which GPUs and maybe deal with changing load from the upper layers. And then on top of that, you need a control plane. And so for this, we ended up building an API in Go. Big Go fans here. Like we came from the Docker and Kubernetes ecosystem, so that's not surprising, but it's a really good choice of language for these sort of systems, primitives. And what does the API layer or the control plane need to do? It needs to handle auth, users, integration with OIDC in an enterprise. It needs to have concepts for like role-based access control, so that maybe you've got data sets in there. You need to control who can access them. You might build applications there, and you might want to control which teams or users can have different roles on each application. That's fairly typical. You then also need a web interface. We found that people generally want something that's familiar, so something that feels, looks and feels a bit like ChatGPT or Claude from Anthropic. You probably also want things like metering, like so you can see which team has used the most GPU resources this month and things like that. So you can keep track of like if one person is hammering the cluster, then like maybe put limits on them or something like that. So that's the control plane. And then on top of that, this was where it gets more interesting, I guess, is I really see kind of 3 pieces side by side, which is the models, the knowledge, and the integrations. And the models, we've already talked about a little bit, but when we started back in 2023, we made this bet that the open source models were going to get better really quickly. And then like fast forward to the start of this year, you get DeepSeek in the headlines, and it's like, oh yeah, that bet paid off. Like now people are actually seriously interested in running this stuff locally. Because the open source stuff is getting better really quickly. And that continues to happen if you just look at like the latest Llama 4 release. Some people are saying Llama 4 is not that good, but I'm actually quite impressed with it. And then like Qwen 3 and all the good new open source stuff coming out from all over the world is compelling. It's on par with the best models you can get from OpenAI and Anthropic at this point. And I guess you're going to come onto the question of why run it locally, but like obviously, like we'll touch on that in a minute. But then from a stack perspective, you've got the models, different models are good at different things, and you get different models of different sizes. So there's like models like Aya from Cohere that are very good at being multilingual. There's some models are better at chain of thought than others. Some models are faster at responding than others. So you might want to have a mix of the different models that you select and make available to your users. Then you've got the knowledge piece, which is, like I mentioned already, that kind of vector store piece of like, I want to be able to ingest documents into my system. I maybe want to set up web scraping so I can scrape a website every hour and like keep that updated. Or I might want to connect to a file store or SharePoint or whatever and like automatically scrape. Maybe I'm a financial institution like some of our customers, and we've got maybe 20,000 research PDFs on different research topics, and we want to surface those to our researchers in a way that they can ask intelligent questions about them, find the right PDF more quickly, and so on. So that's that whole kind of knowledge piece. And then the third piece is this API integrations, and then also so that's really a three-step process. So if you take a user's query, like a question, like what's the current US dollar sterling exchange rate? The model isn't going to know because it finished training like the middle of last year or something. Like,
sure. Yeah,
it doesn't know the current exchange rate. So you then do a three-step process. The first one is like you establish whether the user's query needs an API call. If it does, then you get the model to construct an API request body, and then the system makes the API request. And then the third step is that you summarize the API response back to the user in non-technical language. So you don't want the model to be like, I got a JSON response that said blah, blah, blah. You want it to say the current exchange rate is
yes.
blah. So,
yes.
That API integration piece is interesting. And then the other thing you can do is if you, in your control plane, the user will kind of auth with your kind of primary like OIDC provider, like Active Directory or whatever it is. But the user might then also want to like connect other accounts that they have with other services so that the system can make API calls on their behalf. So you might want to loop in your Atlassian integration so that you can have the user query private data that is specific to them or their team in Jira and Confluence. You might want to loop in Google Drive or Office 365 or wherever else your data is stored. And so what you can do is you can loop in these external providers, and then you can automatically have the system keep like valid tokens for those users for all of those external services. And then whenever the user asks questions about their Jira, then you can use the latest valid token for that user to make those API calls on that user's behalf. So that's part of that kind of integration piece. Then, and I'll wrap this up quickly, but there's some really important pieces that are on top of those three boxes. So I talked about and we can talk about fine tuning as well, but that's a whole separate piece. But these are the main ones. But then what's really important on top of those three boxes is this abstraction to describe. Now we call them AI apps. But if you think about like the different configuration that you might have for model, the knowledge that you've connected to that model, the APIs that you've made available to that model, and there's also things like the system prompt, which is like tell the model how to behave. Think about packaging that up in a configuration format, and then think about versioning that configuration format. Because that's how we do software and DevOps, right? We version control Kubernetes manifests in Git. It's called GitOps. It's very popular. And my strong conviction is that we should be doing the same thing for Gen AI applications, and that we need a spec for defining these applications that consist of model plus knowledge plus API integrations, and maybe other things like MCP servers as well. And we need to be able to version them, and we need to be able to test them. Because if you can't test your systems, then you can't put them into production, really. Like we've learned that the hard way from software engineering. So the thing that I'm really big on is that, and what we added also to our spec in our product, is the ability to specify in AI land, it's called evals. But evals just means tests. And as software engineers and DevOps people coming into this world, you can look at evals and you can say, oh, that's just a way of writing tests for my GenAI applications. And why do I write tests? Well, it's because when I do my Jira integration and I teach the model how to write JQL by tweaking my configuration and giving it like information about how to ask certain questions of the backend, I want to be able to write 10 tests for the different cases that I made work. And then when Bob comes along tomorrow and makes a change to that prompt, I want Bob to be able to automatically run the tests, the 10 cases that I cared about working yesterday, and make sure that he didn't regress any of them. And I want all of that to run in my existing CI system, and I want it to run on every push to every branch, and I want it to be a gate for merging to main and releasing to production. And that's where I connect this into that kind of software and DevOps world. That kind of spec piece on top, I think, is super important.
No, and you bring up such an amazing point, because I don't think this whole concept of versioning and lifecycle management is talked about enough. Because I think I'll use a SaaS-based example of like, okay, an Anthropic or an OpenAI, like you can go ask it something, and depending on which version of the model it's using, and even within that model, sometimes data is added, sometimes it's changes, and so it's a big black box, right? And you can ask it something today and ask it something 6 months from now, and you might get a different answer.
Yeah.
And for many organizations that are out there, especially in highly regulated organizations, like that's just a non-starter, both from a data privacy, data regulations, as well as if I ask it the answer, I need to have consistency back. And the only way to control that is, through some of these more classical CI/CD methodologies and DevOps methodologies of versioning and lifecycle management, and not just the model, but the data that is both trained against the model as well as looked up.
Yes.
And so I know it's such a fantastic point. And let me kind of maybe dig into that just a little bit more, because I think there's this intersection here of like DevOps and talking about DevOps and MLOps, because I feel like they're today seen as very different platforms and very different methodologies, right? And using a lot of different tools at times too, but you're talking about, like, at the end of the day, like at its most basic level, AI is just another app that runs in containers on Kubernetes.
Yep.
And I don't think everyone kind of doesn't realize that at the end of the day, like, hey, it's just another app.
It can be. Yeah.
Right. And let's talk about that. Like when it comes to the MLOps aspect of all of this, right? Yeah. Like, is it truly its own thing? Is it truly it's just like everything else, but with a different name? Like, tell everyone a little bit about where we're at when it comes to MLOps.
That's a really good question. So I mentioned my second company was an MLOps business, and it was pre-GenAI. And at that time, we were targeting companies who were creating their own machine learning models. And some people were calling them AI models, but it was like one example was like a traffic sign classifier if you're doing a self-driving car system or something, because that was seen as very futuristic, kind of pre-ChatGPT, and so it's interesting because there's been this evolution of the meaning even of the word MLOps. So to begin with, and kind of back in my previous startups day, and we founded the MLOps community, by the way. Like at the very end of that company, unfortunately, we had to shut the company down at the start of COVID. But the last thing we did basically was we started this project called MLOps.community, which has now, thanks to my friend Demetrios, has grown into a Slack channel with 20,000 people, very active on YouTube, and we do meetups all around the world, which has been amazing to see that thing grow. So there's loads of content there, but the meaning of MLOps kind of shifted. Initially, it meant like the infrastructure that you need around companies doing their own modeling, their own ML models, And so you'd often get that like insurance companies, like models for predicting risk and for pricing quotes and things like that, that would take lots of tabular data and generate features with feature stores, and then you'd train these models with like XGBoost or whatever, and then you'd save the pickle file in an S3 bucket or something, and that was what people meant when they talked about MLOps. And there are companies that still do that and still create their own models. But then ChatGPT happened, large language models exploded, and this notion of foundation models showed up, which is that there's other companies out there are going to train your models for you, especially when it comes to large language models. It costs tens of millions of dollars to train one of these things. Most companies are not going to train their own large language models, and they should not do that. And that led to this new notion of a different discipline, which some people called LLM ops, which is a bit of a mouthful. I don't really like saying it out loud, but it's this idea of, well, what's the infrastructure you need to build around an LLM? It's not training infrastructure, and it's not really kind of feature stores and being able to do kind of like fast online retrieval of tabular data. It's much more around having a large language model either in your infrastructure or even just building the infrastructure you need around calling an external one via an API. And it's around like prompt management, like templating your prompts. It's around vector stores for this data retrieval when you're feeding context into these language models. And so I would try and distinguish those two different disciplines. And I would say MLOps is still alive and well. Or you can include LLM ops in MLOps, and it's kind of up to you. But I generally think of them as separate disciplines. MLOps is what people who are companies that are still training their own models are, maybe classical ML models, you could call them now. And then there's LLM ops, which is this whole discipline of like how do you deal with all of the infrastructure you need around a large language model to make use of it in your business. And that's kind of the pieces I've described. So yeah, hopefully that's a useful distinction.
No, it makes perfect sense. And I like that clarity. And it's also a way I hadn't really thought about it before. But so last topic I wanted to touch on today is this idea of like, especially as we kind of move from Gen AI into agentic AI, but it's still, I think, as we're getting smarter and more purposeful around Gen AI and inferencing in particular, we're starting to see more and more data pipelines really being backed by, as you mentioned, multiple models, right? And sometimes in multiple locations, right? Like could be for, a latency and geographic dispersion reason. It could be for data privacy and security or, data compliance and regulation or data sovereignty. And so how do you handle this both from a scheduling and an interface standpoint, right? Like, because at the end of the day is everything being called and maybe abstracted away and it's just simply down to simple API calls, just like it would be as if it was a SaaS service? Like when it becomes complex, not just with multiple models, but multiple locations, how does that affect the operations of all of this?
Yeah. And so, and maybe I can also kind of touch on like the reason why you would want to do private deployments at all at the same time in my answer here. I'll just touch on that and then I'll come back to your question.
Please.
If that's okay. So
absolutely.
Like when we launched the first version of the product back in 2023, like in December 2023, we went into the market with these two hypotheses. The first one was that people would want to run their LLMs locally on their own infrastructure for data privacy and security reasons. And the second one was that people would care about fine-tuning for knowledge. And don't worry, I'm not going to go into that. But what we heard was the market said, hell yeah, to running LLMs locally. There's loads of different reasons why people want to run their own large language models and have control over the data. So, for example, all of European telco is regulated to not send their data to American tech companies, for example. The same is true for German healthcare. And there's lots of sort of financial institutions, for example, who just can't send their data to an OpenAI or an Anthropic because their security and compliance people say we need to have 3 copies of everything we run in production. So that we can cope with one of them going down, and you can't have an external API be one of those pieces. So what we saw was immediately this kind of strong positive feedback about like, yes, we want to run things privately, we want to maintain control, and honestly, one of the main drivers for that is that these big AI labs, like the proprietary AI labs, like OpenAI and Anthropic, like what they need is more training data to train like the next version of their model on. And that's why they want everyone to connect to their API and start sending their data to them so that they can train on it. And people are rightfully concerned about not wanting their commercially sensitive IP to be included in the training data for the next round of the model. And so that's a large driver for people wanting to do private deployments at all. So then I'll come on to kind of really your question, which is, what about these sort of more complex deployments that involve agentic flows that use different models for different parts of the equation? And I would really urge people, and also for different kind of geographical reasons, you might want to keep all of your data in Europe, like geographically in Europe, for example. And what I would encourage people to do, whether they look at Helix ML or not, like even if you're just rolling your own on Kubernetes, is look at having a consistent way of deploying the entire stack across different geographies, across different infrastructure. And look, for example, at running VLLM on Kubernetes. I gave a talk at KubeCon about this recently with my colleague Priya about how you can use just the open source pieces to kind of do this yourself. And have a consistent layer like Kubernetes with VLLM or Helix ML or whatever that allows you to stand up these different pieces in a consistent way across diverse infrastructure, whether it's private cloud, public cloud, different environments. And and then also think about how you can have this configuration for like what you're building out of those pieces instead of having code for every single implementation. Something I've heard a lot of customers talk about is how one of the big problems they have is what they call RAG sprawl, which is where they've got 10 different teams building different RAG systems using different stacks. And it's kind of like, my colleague Hannah talked about how this was the same in the early days of Kubernetes. You'd have like Kubernetes sprawl. You'd have every team used a different like stack for Kubernetes, and then unifying this thing was a nightmare. So also think about configuration over code for how you define these applications, the data they use, and then it becomes a lot easier to secure that centrally rather than trying to get every different team doing a different RAG implementation with 10 different tools like Llama Index and Milvus or like OpenAI and like whatever. Think about basically building a platform team that is able to deliver these Gen AI pieces as a service to the upper layers in the organization. Sure.
Yeah, it's interesting too how many concepts in our industry are transferable from one technology wave to the next. Right? Like, you had cloud sprawl and you had Kubernetes sprawl. Like you always have these early days where everyone's experimenting, everyone's standing stuff up, and everyone's just kind of doing their own thing. And then at some point it gets big enough, and then it's like, oh gosh, we got to unwind all this and figure out how to consolidate all this and make it much more efficient over time. And we've had this, and we've seen it in our industry time and time again. I mean, you can almost count like clockwork how some of these technologies will evolve over time. So that's fantastic. And I think that's actually a great place for us to stop today, Luke. I'll ask a final question. If anyone out there is interested in reaching out to you or learning more about Helix, what's the best way to get started?
Yeah, check out our website, helix.ml. And please drop me a personal email. I'd love to talk to anyone who's listening to this show who's interested in talking about any of these topics, especially if you're interested in us helping you put some of these systems together, or even just to compare notes on how you're doing it and maybe share some insights. So I'm Luke at helix.ml. Feel free to email me directly, or Luke Marsden on LinkedIn. So thanks so much.
Fantastic. All right, Luke, thank you very much for your time today. And on behalf of Brian and myself, thank you everyone out there for listening. We certainly appreciate it. If you enjoy the show, please tell a friend. Please leave us a review if you can, wherever you get your podcasts. And of course, we'd always love to hear your feedback as well. show@thecloudcast.net. For that, I'm going to wrap it up this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.